Okay, so in this video I'm going to explain one of the most basic and important principles in electronics, which is Ohm's law. Now, Ohm's law was created by German physicist Georg Simon Ohm. He stated that the electric current flowing through a metal wire is directly proportional to the potential difference across its ends, provided the temperature stays the same. Now, maybe you don't understand what any of these words say, but what Ohm gave us is basically this little equation. Now, this equation can help us get a lot of important things in electronics because it links three very important factors about electronics, which is voltage, current, and resistance. Ohm's law helps us link all of these and helps us to get these values within a circuit. Now, before I explain how to use the equation or where to use it, I'm going to explain each one of these. So, the first one I'm going to explain is voltage. Now, voltage, to explain a little bit easier, I'm going to kind of make an analogy to water flowing through a pipe. So we can think about voltage like being the pressure that pushes through the electricity through a cable. Here the cable, of course, it's the pipe, and the water is going to be the electricity. So we can think about voltage as the driving force of the electricity through the cable, or the pressure. Of course, this is just an analogy. It's not actually water flowing through a pipe. It's electricity flowing through a cable, but to simplify it, it kind of works like this. The second factor that I'm going to explain is current. Current is going to be represented with an I, and it's measured in amperes. Oh, I forgot. Voltage is measured in volts and current in amps. So we can think about current, again relating it to water, as the amount of electrons that go through. This, relating it to water, would be the amount of water that goes through. So this is basically the amount of flow in the amount of electrons. So this is current. So the last factor of the equation that I'm going to explain is resistance. Now, resistance is going to always be measured with ohms, and it's going to be represented with an R within our equation. Now, to explain resistance with a previous kind of metaphor, we're going to see it as the kind of the pipe, the size of the pipe where the water goes through. Of course, a larger pipe is going to allow more water to go through. A smaller pipe is going to put more resistance to the water, and less water is going to go through. So this is kind of what a resistor does within a circuit. It can regulate the flow of the electrons, or it can limit them. So if you have a regulator with a higher value in a circuit, then it's going to allow a lot less electricity to go through. So yeah. Now that you kind of know what these mean, maybe you knew before, but I just explained it. So now I'm going to explain how you can use them in a bit of an easier way. So to do that, I'm gonna have the original equation here, and what we're gonna do is we're gonna draw a little triangle here. So this little triangle, we're gonna use it to kind of represent the equation in a simpler way. So what we're gonna do is we're gonna put the values of the equation in here. We're gonna put the voltage, we're gonna put it always on top. We're gonna put the current here. We're going to put the resistance here. So now we have this little triangle. So using this, we can kind of apply the equation in an easier way. So I'm gonna do a little example here. So we're gonna have a very simple circuit here. This is the battery, this is going to be the resistor, and here we have our little triangle that we're going to use. So what we're going to do is we're going to imagine that there's a 15 volt of energy going out of the battery, and we're gonna want to get half an amp of current coming out. So we're gonna have this, the initial energy, and the current we're gonna want. So what we need is gonna be the resistor. So we're gonna now substitute the values within our little triangle. We have the volts, which is gonna be 15, and we also have the current, which is gonna be 0.5. So now you can see that this kind of resembles division. So what we're gonna do is exactly that. We're gonna divide this over this, and if we do it, we would come up with the resistor value, which is gonna be 30. So the resistor is gonna be 30 ohms. So you see here we use this little triangle to get the value that we didn't have. So okay, let me do another example. So here we have again another circuit. Now this time let's imagine that instead of having this and this, we can have the value of the resistor, which is going to be 40, and we're also going to have the value of the finishing current, which we're going to want it to be 2.5. So now we're going to again substitute this with an original little triangle. So now we're going to have 40 as the resistance. We're going to have 2.5. This is going to be amp. So we're going to have 2.5. Now this, since they're in the same level, we're going to just multiply them. So we're going to multiply these two, which will come out as 100, I think. Yeah, 100. So to get this amount of current flowing through the resistor, we would need to have 100 volts coming out of the battery. So this is one of the uses in mathematics that the law itself has. But this circuit and this resistor thing is very common in a lot of things we have now, because when the resistor limits the amount of energy that goes through, it creates heat. So this is the case in some old toasters maybe, or some house heaters. That's what it does. It has resistors that create heat, and then we could turn the electricity into a more usable thing for us, which is of course heat. So yeah, that is Ohm's law, and that is how we use it.